I will talk about the concept of annuity in finance. I will share the PPT, then I will take you through the concept. Now, what is annuity? Annuity is a stream of payment of equal amount. Now, broadly, there are two types of annuity. One is called the ordinary annuity, this one, when the payments happen at the end of the year. And the other one is called the annuity due, when payments happen at the beginning of the year. Now, what is the meaning of this? What is the payment happening at the beginning of the year, end of the year? Let us say a year starts at, let's say, 1st of April and ends at 31st March. So if you are depositing a payment at the end of the year, like 31st March, then it is an ordinary annuity. However, if you are depositing the payment at the beginning of the year, that is on 1st of April, then it is an annuity due. So there are broadly two types of annuity depending on when you are depositing the payment. Whether you are depositing the payment at the beginning of the year or you are depositing the payment at the end of the year. So if you are depositing the payment at the end of the year, it is called an ordinary annuity, which is very, very common. And the other one, when the payments are deposited at the beginning of the year, it is called annuity due. Now, some examples of real life annuities. Now, let us say there is a company, either a pension fund or a insurance company, which says that you pay 1,000 rupees today and I will give you 150 rupees next 8 years. So it is one kind of annuity. So there is a stream of payment that you are getting from 150 on first year to 150 on the 8th year. So it is a stream of payment. So it is an annuity. Now the other example could be that the company will say that you pay 200 5 times up to 4th year, and then we will pay you 300 for the next 4 years. So this is another kind of annuity. So you pay for 5 years and then the next 4 years we will pay. The another kind of annuity could be that the company will say that you pay 100 rupees for the 8 years. For 8 years, 100 starting from year 0 to year 7. So 8 years you pay 100 rupees, total 800 rupees, and then we will pay you 1,000 rupees. So this is also one kind of annuity. The other one could be that the company will say that you pay 1,000 rupees today, we will pay you 50 rupees till you are alive or till your nominee is alive. Let's say if you demise, or you did not survive, then your nominee, whoever is your nominee, your spouse, your child, whoever is your nominee, he will also get the payment till he survives. So 1,000 rupees you pay and you keep on getting 50 rupees. So this is called a perpetuity, which doesn't have a definite end period. Like in other examples, where there is a definite end period, here 8th year, so there is a definite end point. But in case of the last one, there is no definite end point, and this is called a perpetuity. So perpetuity is one kind of a stream of payment where there is no definite end period. Now we look at how to calculate the future value of an annuity. So if you look at this example, I have given the example of ordinary annuity and the annuity due. So let's say ordinary annuity. As I have told you, in ordinary annuity, the payment will be made at the end of the year. So 31st March, 100, 100, 100, 100 and 100. So 500 rupees at the end of every year has been deposited. So we will calculate what is the future value. Now this 100 rupees that has been deposited will grow for how many years? It will grow for 4 years. Now this will grow for how many years? It will grow for 3 years. And how many years this last one will grow? It will grow for 0 year, because you are depositing the money at the end of the year. So there is no scope for growth. So we will calculate what is the value of this stream of payment. This is called an ordinary annuity. I have also given the example of an annuity due. Now here you will notice that the payment is at the beginning of the year, 100 on 1st of April, then 100 on 1st of April. So at the beginning of the year, I have made the payment. And how many years these payments will grow? This 100, since it has been deposited at the beginning of the year, this will grow by for 5 years. This will grow for 4 years. This will grow for 3 years. And this one will grow for 1 year. Now we will calculate what is the future bill. Now if you put the normal future bill formula, A into 1 plus R to the power n. So 100, this example, 100 into 1.08. I have taken the interest rate as 8%. So 100 into 1.08 to the power 4. Next one is 100 into 1.08 to the power 3. Like that I have calculated, and total you have got 5.86.66. Now the FB of annuity due will be 100 into, this is for 5 years. So here 1.08 to the power 5. Like that you calculate, you get 633.59. So in these two, if you compare, you will find that the FB of annuity due is higher than the FB of ordinary annuity. Why? Because in case of annuity due, you are making the payment at the beginning of the year, while in case of an ordinary annuity, you are making the deposit at the end of the year. So the future value of annuity due will be higher than the future value of an ordinary annuity. Now let us calculate the present value of the annuity. So same way, 100 rupees at the end of the year in case of ordinary annuity, and 100 rupees at the beginning of the year in case of the annuity due. Now how many years it will for calculating the present value, how many years you will bring back? This one you will bring back by 1 year, this one you will bring back by 2 years, and this one you will bring back by 5 years, right? Now in case of ordinary annuity, since you are depositing at the beginning of the year, so this one you will bring back by 0 year. So because it is at the beginning of the year, and the last one you will bring back by 4 years. Right? Now if you calculate the present value of ordinary annuity, so this will be 100 divided by 1.08 to the power 1, and the last one will be 100 divided by 1.08 to the power 5. So you get 399.27. Similarly, the PV of annuity due will be, this one will remain same, because at the beginning of the year you are depositing. So 100 plus 100 divided by 1.08 to the power 2, this one, and this one will be 100 divided by 1.08 to the power 4. Now and the value we get 431.21. So when you compare this PV of ordinary annuity and PV of annuity due, you find the PV of annuity due is higher. Why? Because in case of annuity due, you are making the deposit at the beginning of the year. So present value will be higher in case of PV of or in case of annuity due. Now we calculated the future value of annuity and also the present value of annuity of both types of annuity, the ordinary annuity and the annuity due, using very simple what you called arithmetic. Now there are formula for a long stream of payment or for variety of interest rates. You cannot calculate in a manual method, so you have to use the formula. Now future value, this is the formula for future value of annuity. Future value of an ordinary annuity, you have to use this formula. So if you put that 100, so this is A into 1 plus R to the power n minus 1 divided by R. So where R is the interest rate, A is the amount that you deposit every year, n is the number of payments. Then if you put the formula, you get the same amount that you have got through manual calculation. And this is the future value of an annuity due. So the formula is little different. So what you do, you just multiply whatever formula is there for ordinary annuity, there you multiply 1.1 plus R. Why? Because here you are depositing the payment at the beginning of the year. So the time for growth is higher in case of ordinary annuity, and you will get a higher amount. So if you put the formula 100 into this one, and here you are multiplying 1 plus R, is 1.08, then you get 633.59, which is same as that you have calculated in manual method. Now, when you compare these two, you will find that the future value of an annuity due is higher than the future value of an ordinary annuity. Now, this future value of an annuity can also be calculated from annuity table. There is annuity table from which you can find out the annuity factor, and you can also quickly calculate the future value. However, the restriction is that in that table you will find only the whole numbers, like the interest rate will be 1%, 2%, 3%, 4%, like that, whole numbers. And similarly, the number of periods will be whole numbers, 1 year, 2 year, 3 year, 5 year, 10 year. So it will be whole numbers. So if the both N and R are whole numbers, then it is easier to use the future value annuity table directly, and you can avoid using the formula. Okay. The next one is called the present value of annuity. How do you calculate? So for present value of ordinary annuity, you use this formula, and you get 399.29. When you put the values for A, R, and N, and use this formula, you will get 399.27 in case of an ordinary annuity, which is same as what we had calculated manually. And if you calculate the present value of annuity due, you will get 431.21. Right? Same formula, a little different formula. This one, if you put, you will get 431.21. And these two values are same as what we had calculated manually. And you will find the present value of annuity due is higher than the present value of ordinary annuity. Why? Because in case of annuity due, you are making the payment at the beginning of the year. Right? So that way, the present value will be higher. Similar to the future value of annuity due, the present value of annuity can also be used to calculate the present value of a stream of payment if the value of N and R are whole numbers. You can look at the table and quickly take the annuity factor and then find out what is the value. It is possible. So you don't have to use the formula. But if the value of N and R are fractions, then you cannot use the table. You have to use this formula. Right? Now, next we come to what is the future value of a growing ordinary annuity. Now, it is not that all the time the stream of payments is equal. Sometimes the stream of payments grows at a particular rate. Now, here I have taken the example of ordinary annuity. So 100, 100, this is the ordinary annuity, but we are telling that this time the annuity amount is growing at the rate of 6%. So this first year is 100, then 106, 112.36. So it has been growing at the rate of 6% over the years. Now, if that is the case, then what is the future value? So now this one will grow by 4 years, this one by 3 years, this one by 2 years, and the last one by 0 year. Now, if you put the same formula of future value, A into 1 plus R to the power N, and calculate 100 into 1 plus 0.08 to the power 4, 106 into 1.08 to the power 3, and the last one is 126.25, 1.08 to the power 0. Then you will find 655.51. So the future value will be higher compared to a constant what you call it, ordinary annuity, where it is all 100. Since it is growing at the rate of 6%, the future value will be high. Okay, so you can use this way. Now, similarly, you can also calculate the present value of a growing ordinary annuity. So, same example we have taken. This 100 is the constant, but it is growing at the 6%. So, these are the values. And then, how do you calculate the present value? 100 divided by 1.08 to the power 1. In case of future value, we were using 100 into 1 plus R to the power N. But in case of present value, we use 100 divided by 1.08 to the power 1. So if you use similar values, then you get 446.13. So the present value of an ordinary annuity will be different from the present value of a growing annuity. Now, you can also use the formula to calculate the future value and present value of a growing ordinary annuity. Unlike the previous example, in a tabulator format, we have calculated in a manual method. You can also use the following formula to calculate the value. So for future value, you have to use this formula, where A is the amount deposited every period, R is the interest rate, N is the number of periods, G is the growth rate. At what rate the amount is growing over the year. So G. So if you use the formula, you get 655.51, which is same as the this one, same as the previous slide. Okay. Now you can also similarly calculate the present value. So you present value, you put this formula. So you put this formula, same interpretation of the symbols used, A, G, and M. And if you put the formula, you get 446.13 as the present value of the growing ordinary annuity. So this is same, 446.13. So manually here we have calculated, and here we have used the formula to calculate. Now when you use a formula to calculate, it is easier, because manually it is difficult when the N is high or the number of payments that you are getting is high. It's very difficult. Or when the interest rate is a fraction, it is not a whole number, then calculating manually is very difficult. So it is easier to use a formula. Now you come to the last slide, which is called the perpetuity. Now what is perpetuity? Now perpetuity, as I had told at the first slide, that it is a stream of payment which has no end date. It continues to be deposited, it continues to flow. Now how do you calculate the present value of a perpetuity? Present value of a perpetuity is equal to PV is equal to A by R. So if somebody says that I will give you 100 rupees till eternity, or there is no end date, then how do you calculate what is the present value? So 100 divided by 0.08. Here we have used the interest rate to be 8%. Then you get 1250 as the present value. All right. Now similarly, you can also calculate the present value of a constantly growing perpetuity. If somebody says that I will keep you giving 100 rupees, which will grow every year at the rate of 8%, keep on growing at the rate of 6%, then you use the formula A by R plus R minus G. R is the interest rate, G is the growth rate. Then you calculate the present value, it comes to 5,000. So if it is an ordinary perpetuity, the present value is 1250. But if it is a growing perpetuity, which is growing at 6%, in this example, the present value will be 5,000. So simply by using the formula, you can calculate what is the present value. So what we have essentially learned today is the concept of annuity. Then what are the two types of annuity, namely the ordinary annuity and the annuity due. Then we have also calculated the future value and the present value of ordinary annuity and annuity due. We have also seen how to calculate the present value and future value of a growing annuity. And then finally, we have also looked at how to calculate the value of the present value of perpetuity. Now, this concept of annuity is very relevant in insurance industry, or many times in pension funds. They use this concept where either you deposit a stream of payment and you get a stream of payment, or you deposit a lump sum and then you get a stream of payment. So all their plans are based on this the concept of annuity. I hope you have understood this concept. Thank you very much.